Chapter 6, Section 7, Standard B. The objective is to learn to compute compound interest. Our essential question, what is the formula for computing compound interest? Here's a comparison of simple interest to compound interest. Both of these are depositing $500 into a bank at 3% for the interest rate. The left-hand side is simple interest, the right-hand side is compound. They both begin with $500. You can see after year one, they both have the same dollar amount, $515, because it's both 500 times 3%. What happens in year two is the amounts start to change, not by much, but by a little. In year three, they change even more. Where is this change taking place? Well, if you notice, when you compute simple interest, you always keep that same starting amount, $500, and you multiply 3% times that every year, then you do that times the number of years. In compound interest, it changes. Instead of taking 500 and adding it on to the interest every time, we get to take the interest off of what the amount was previously. So since year one gave us $515 total, that's the amount we get to add to, and that's the amount we get to multiply 3% of. So that increases each month, or each year, excuse me. So in year three, we've increased again, so we would now multiply our new total times 3% and add that to our total from the previous year. So in simple interest, you can add $15 each year because you'll get the same amount no matter what the year is. Compound interest, each year you must use the new value from the previous year to calculate the interest. So you're always going to be gaining. When you're making money, that's a great thing. When you're having to spend the money, maybe not such a great thing. But let's look at the ways you can compute it, how the formula is set up, and how it's different from simple interest. Here's the calculations for a 5-year loan at 10%. So year 0 would be the starting spot, a $1,000 loan, 10% interest would be $100, so at the end of the year, the first year would be $1,100. Now go into year 1. Now you have to take 10% of $1,100, which increases your interest to $110, add that to the start of the year loan, which is $1,100, for a total of $1,210. Carry that over to be the starting amount, take 10% of $1,210, add that new interest amount to the previous total to get $1,331. So you can see that we're growing every year. Now that's great, but what if this is a 10 or 20-year loan and you don't want to compute year by year? There is a definition, there is a formula. Definition for compound interest is interest paid both on the original amount of money and the interest it has already earned. Here's the formula. It looks overwhelming, but let's break it down. A stands for the total amount. P is the principal, just like in simple interest, it's the starting amount, multiplied by 1 for 100%, plus R for the percentage rate in its decimal form, and the number of times compounded a year, and T the number of years. So you can see N is in two different places. If we're only compounding once a year, then N doesn't have a big impact on anything. But if we start to compound semi-annually, quarterly, monthly, then it's going to change our values. So let's give it a try. You are signing up for a bank account that offers 3% interest compounded annually. That means once a year. If you deposit $150 in your account to start, how much money will you have at the end of 1 year and the end of 5 years? Let's look at our information first. 3% interest compounded annually. If you deposit $150 into your account to start, the question asks how much money will you have at the end of 1 year and then at the end of 5 years. So for this first part, we're going to use 1 year. Here's what the letters stand for again. Here's our equation. So for 1 year, we don't know the total amount. We know the principal is $150. We know the rate is 3%, which would be 3/100. N, the number of times compounded a year because it's annually, would be 1. T, the number of years, would be 1. So when we set this up, Here's what it'll look like, substituting all the numbers in for the correct variables. Remember to follow order of operations, so we can deal with that fraction first. And dividing by 1 doesn't change anything. Also in the exponent, multiplying by 1 doesn't change anything. Add what's inside the parentheses. I took away the 1 for an exponent because it doesn't change the value. Multiply. And the nice part about this formula is it gives you your total right away. This is not the interest. This is the total amount of money after that many years. So after 1 year, you would have $154.50. So if you just wanted the interest, you would have to go ahead and take your principal of 150 subtracted from your total, and your interest was $4.50. Let's try part 2 for 5 years. Notice that everything looks the same except the exponent. Now we changed t to 5. Simplify inside the fraction again, and 1 times 5 is 5. Add inside the parentheses. Most important step here is to remember not to worry about typing this in your calculator the way it is, but to remember that you need to do the exponent first. A lot of calculators will do things in the order that you type them. So if you forget to do the exponent first, you may end up with a very, very wrong value. So we take 1.03 to the 5th power. We will have to round occasionally because these numbers do go on for a while sometimes. Multiply by 150, and we get $173.89 after 5 years. So if we wanted to know how much total interest we've made, we would again subtract our starting amount, and the interest we've made over 5 years is $23.89. How are we doing so far? Hanging in there? It's not quite as simple to compute as simple interest. However, simple interest is not used very commonly. Compound is much more common, especially with loans, with savings accounts, things that we're going to be, or you're going to be familiar with in the future. What if we compound 3% interest semi-annually for 1 year and 5 years? So we're going to use that same dollar amount, 150. Semi-annually means twice a year. So now we've changed just that piece of it. We have our interest is the same, semi-annually, 1 year and 5 years. We're going to do 2 problems. So down here, the part that changed from the previous page was that n is 2. That's the number of times compounded a year. So when we plug our numbers in, n becomes 2, which happens to change the fraction, and it changes the exponent. So we go ahead and simplify that fraction and get 0.015, and our exponent becomes 2. Add inside the parentheses. Again, we make sure to do the exponent first. We'll have to round a little bit. Multiply by 150, and we get $154.53. Let's look at if we did this for 5 years. Now we're changing t to 5. So our formula is set up the same as it was in the first part, only now it's 2 times 5 in the exponent. Simplify inside that fraction. 2 times 5 is 10 for the exponent. Add inside the parentheses. Take 1.015 to the 10th power and round it, or if you keep that number in your calculator, just hit times 150 as soon as you're done with that. And we had a total of $174.08. Again, if you wanted the interest for each year, subtract your original principal, and for 1 year, we made $4.53. Over a span of 5 years, oops, sorry, decimal in the wrong place, we would have $24.08 in interest. Now this isn't computing what it came out to be every year because it's not going to be equal every year, but it would give us the total interest after that many years. So we've done all this work. What was the purpose? Well, let's look at some differences and some similarities. We started with $150 every problem. Compounded annually for 1 year, we would have had $154.50. This was annually, compounding one time a year. Semi-annually, compounding twice a year, was $154.53. So only a difference of 3 cents over a span of 1 year. Let's look at 5 years. Compounding once a year, we had $173.89. Compounding twice a year for 5 years, $174.08. So again, not a major difference, but if you imagine larger sums of money and you imagine longer periods of time, this difference could be significant. Let's do one final comparison. What if we did this with simple interest? What would our total be after 5 years if we received 3% simple interest on a principal of $150? So remember, that is IPERT. We're looking for these things. I, we do not know. P is 150. R is 3% or 0.03. T is 5. To get the total when we're done, we'll need to add the interest to the principal. So we multiply 150 times 300 times 5. We get $22.50 in interest. Add that to 150, and we have $172.50 total. So here's our 5 years all compared with the same principal, same interest rate. Compounded annually, $173.89. Compounded semi-annually, $174.08. And annual simple interest, $172.50. So I'll let you draw some of your own conclusions here, and there are obviously a lot more things we could do. Like I said, we could compound it quarterly, which would be 4 times a year, monthly, daily, weekly. We could try all kinds of things. So if this were money you were earning in a savings account, I want you to think about, would you prefer to earn simple or compound interest on a savings account? You may also want to think vice versa. What if you were paying a loan or borrowing money? Would you prefer simple or compound interest when it comes to borrowing money? These are important skills to have as you go on in your future. Make sure your notes are filled out completely. On the left-hand side, write questions that you either can answer from your notes, questions you still have from the lesson. Review your notes, highlight, give it some time, give it some thought, and complete the summary in about a day.